Bismillahirrahmanirrahim. Assalamualaikum and a very good evening. I bid to Dr. Tazli and Dr. Raihan. My name is Muhammad Shafiq bin Sanusi, ID 18444, and for today proposal defense, I will be presenting the topic of biodegradability study of the partially degraded aqueous ionic liquid via Fenton's oxidation. This is the outline for my presentation. Basically, I will be starting with introduction and my literature review, research methodology, and I will end it with conclusions. Chapter 1, Introduction. So, what is ionic liquid? Generally, ionic liquids are salts that exist in liquid states and are labeled as green solvent due to its properties and act as a good replacement for volatile solvent that causes air pollutions. These ionic liquids have several properties generally, which is high ionic conductivity, non-volatile and have low vapor pressures, non-flammable and have large electrochemical stabilities. These ionic liquids are applied in various industries such as ionic liquid is applied in industrial solvent industry, where it is used in coating for titanium surface. Not only that, ionic liquids are applied in pharmaceuticals industry, where ionic liquids are used to extract specific compound from plants for pharmaceuticals, nutritional and cosmetic application. The third application of ionic liquid is nuclear fuel reprocessing, where a non-aqueous electrolyte media for the recovery of uranium and other metals from spent nuclear fuel and other resources. Ionic liquids are also used in batteries, where it replaces water as the electrolyte in metal air batteries, and these ionic liquids are attractive because of their low vapor pressure, which thus increase the battery life by drying slower. Ionic liquids are also applied in gas handling industry, where in examples, 1-butyl-3-methyl-midazolam chloride has been investigated for separating hydrogen from ammonium borate. And ionic liquids are also applied in solar thermal energy, which is ionic liquid act as a potential heat transfer and storage media in solar thermal energy system. Moving on to background of projects. As I mentioned earlier, ionic liquid have low vapor pressure, and due to this low vapor pressure, potential air pollution is reduced. The stability of the IL, however, cause it to accumulate in water stream, which trigger the concern for its effect on water pollutions. This ionic liquid have high resistance towards biodegradation process and could pose higher risk compared to conventional solvent. And research has shown that a method called advanced oxidation processes, or AOPs, are viable to degrade this resistant organic compound to a certain level. However, not all treated water achieve the maximum allowable limit for discharge. The maximum allowable limit discharged by Organization for Economic Cooperation and Development (OECD) stated that for an ionic liquid to be considered as readily degradable, it must undergo a 20-day standard test and must achieve 70% of DOC removal. And one of the common practice is to further treat the partially degraded water to biological treatment called biodegradation. My problem statement is first. Currently, the problem faced in the industry from the ionic liquids application is the impact toward the environment. And cited from Arad Nazik et al. 2011, the stability of the ionic liquid caused them to be poorly biodegradable and remain constant in the environment. And for this project, the ionic liquid that I will be testing is called 1-butyl-3-methyl-midazolam chloride, or BMCl. And even though ionic liquid can be completely degraded, the intermediate form are usually resistant toward advanced oxidation process. However, it yet could be effectively degraded by microorganisms. Thus, in this project, by combining Fenton oxidation and biodegradation processes, it is said to be able to completely mineralize ionic liquid to final product of water and carbon dioxide. As you can see here, this is my research objective. First of all, my first objective is to determine the biodegradation rate of intermediate form after Fenton oxidation. And my second objective is to compare the efficiency of biodegradation of ionic liquid before and after Fenton oxidation. And my third objective is to determine the biodegradation kinetic based on three things, which is total organic carbon value, TOC, biological oxygen demand, BOD value, and also carbon oxygen demand, COD. The scope of my research will be focusing on these two scopes, which is first, we'll be focusing on the biodegradability study of ionic liquid using wastewater sludge collected from UTP's wastewater treatment plant. And this project will also be focusing on comparing the efficiency of biodegradation of ionic liquid before and after Fenton oxidation. Basically, for this project, I'll be focusing on the biodegradation of ionic liquid before Fenton oxidation treatment and after Fenton oxidation treatment. Moving on to Chapter 2, Literature Review. According to Doherty et al. 2006, ionic liquid's molecular structure consists of huge organic cation which is pyridium or imidazolium base with alkyl chain attached to it. And the first room temperature ionic liquid was discovered by Paul Walden in 1914, named ethyl ammonium nitrate. And over the past year, the passion to synthesize this ionic liquid, especially imidazolium base and pyridium base, have been drastically increased according to Doherty. And these ionic liquid are developed with missions to replace volatile solvent, as the common volatile solvent used in industry causes negative effects such as depletion of ozone layers. And according to Branagh and Magin in 2011, ionic liquid does not evaporate as it possesses low vapor pressure. By switching to ionic liquids, it is said could be potentially improve the quality of environments together with saving industries billions of dollars. As I mentioned earlier, ionic liquid consists of two types, which is pyridium or imidazolium base with alkyl chain attached to it. This is what differentiates between imidazolium cation and pyridium cation. As you can see, in imidazolium cation, we have 3 carbon atoms and 5 hydrogen atoms and 2 nitrogen atoms. Whereas for pyridium, it contains 5 carbon atoms, 6 hydrogen atoms, and 1 nitrogen atoms. And for my project here, I'll be using a imidazolium based cation, which is called 1-butyl-3-methyl-imidazolium chloride, which is BMCl. There are several methods to degrade ionic liquid according to Szczerwicka et al. 2009. There are advanced oxidation processes and also biodegradation processes. However, for my part, I'll be conducting research on Fenton reaction, and also I'll be conducting on biodegradations. And third part, I also will be conducting research on the combination of biodegradation and Fenton reaction. Okay, moving on. Fenton oxidation is basically we degrade ionic liquid by using hydroxyl radical that are produced from reaction of hydrogen peroxides and iron. This hydroxyl radical is a non-selective oxidant, which the structure itself will affect the efficiency of degradation. And according to Walling 1975, this process can be modified by adding a huge amount of hydrogen peroxide into the process, producing much more perhydroxyl, which promotes degradation of ionic liquid. The second methodology will be in biodegradation, where a research was conducted for 46 days by Al-Isawi in 2016 on the biodegradation of BMCl and was monitored using LCMS and HNMR. This LCMS is called liquid chromatography mass spectrometry and hydrogen nuclear magnetic resonance, HNMR. The result of this research shows that the total degradation was achieved after 31 days of treatment. This is the graph of percentage of biodegradation achieved by Al-Isawi, and as you can see, the graph shows that complete degradation achieved within 31 days. The third method will be combining Fenton and biodegradation processes. According to Mohidano et al. 2013, he conducted a research on the removal of nitrochloride herbicides from water, and hydrogen peroxide was added at different concentrations. From the process, samples of effluents were analyzed in terms of TOC, COD, toxicity, biodegradability, and intermediate byproduct. After the chemical steps, biological process is executed in a sequencing batch reactor or SBR, and the combining method of Fenton and biodegradation achieve 80% reduction of carbon oxygen demand or COD. Moving on to Chapter 3, Research Methodology. This is my project process flow. First of all, I'll be collecting wastewater sample from UTP wastewater treatment plant, and I will acclimatize the sludge. After that, I'll be beginning my biodegradation study, and as I mentioned earlier, I'll be conducting 2 types of experiment, which is biodegradation of ionic liquid of untreated ionic liquid, and I'll be conducting biodegradation of partially treated ionic liquid after Fenton oxidation. Both of the experiments, the results from both experiments are used for kinetic study of the biodegradation of ionic liquid, and I will gather data and sample the analysis, and I will do sample analysis using DOD, TOC, and COD value, and finally I'll be conducting documentation of data and preparation of final report. This is the procedure for biodegradation of untreated ionic liquid. This procedure is cited from Al-Isawi 2016, who conduct biodegradability study of BMCl using activated sludge. The first step will be enriching the microbial community that was transferred into new sterile media containing BMCl, and concentrated inocula were prepared from this culture, and all this culture was centrifuged into aliquots. Then these aliquots were resuspended and combined into a single microbial pellets. One bottle also contained the abiotic control, which had the microbial inoculate and minimal media without BMCl added, and the pellet was resuspended in a minimal media without a carbon source, and then the sample of the specialized microbial inoculate was added into duplicate. The sterile bottles containing minimal media spiked with BMCl. Finally, one bottle was prepared as an abiotic control, which received no microbial inoculate and was monitored for the non-biotic degradation of BMCl. This procedure continues where the bottles were shaken in dark condition at room temperature, and this biodegradation was specially observed twice per week for 46 days. At each point, the sample were inverted and sample was aseptically removed using pasture pipette, and the samples were filtered through a pore-sized ridge filter. During collections, the absorbance of the BMCl cation in each treatment and control was measured using 210 nanometer using an Epoch 96 well plate feeder. Then the aliquots were prepared in sterile plastic tube, and all the samples were kept in freezer after collection. The BMCl solution, after exposure to activated sludge microbial community for, as you can see there, for several days, was assayed using HPLC, UV, and MS. The second procedure is for biodegradation of partially treated iodide liquid by Fenton oxidation. This procedure was cited from Mohidano at 2016, who conducted an experiment on the biodegradation of the effluent from BMCl after Fenton oxidation. Basically, the first step will be a sequencing batch reactor was set up with pH and dissolved oxygen probes are prepared, and air was introduced to the ceramic to avoid oxygen limitation, and a peristaltic pump was used to feed and discharge the bioreactor, as well as for the addition of sodium hydroxide for pH control, and biomass concentration was varied in order to maintain the organic load using the selected effluent from Fenton oxidation as the sole carbon source. Ammonium sulfate and phosphoric acid were added as nitrogen and phosphorus source, respectively, mineral salts as micronutrient supply. These samples were withdrawn along the biological process for measuring TOC, COD, organic byproducts, and inorganic nitrogen species. This is my Gantt chart, which, as you can see here, I'll be conducting literature review along the 28 weeks, and it is expected for me to start my experimental setup in week 10 on this SEM, and collection of wastewater sludge started from week 11 to week 12, and acclimatization of sludge started from week 12, which is by the end of this semester, and it is expected to complete the experiment by week 18, and preparation for kinetic studies was expected to be done by week 22, where the rest of it will be used for preparation for final report and viva. In conclusion, this project basically will be conducted using biodegradation method and combined method of Fenton oxidation and biodegradation using activated sludge microbial community. And through this project, the efficiency of biodegradation of ILs, which is before and after Fenton oxidation, can be compared based on TOC, BOD, and COD values. The finding of this study, however, might be applied to industry application on how to manage ionic liquid from polluting the water. The expected result from this project is firstly to complete degrading BMCl using activated sludge less than 31 days compared to the result obtained from Al-Isawi in 2016. And my second expected result is to reduce COD value by 100% instead of 80%, which is conducted by Mohidano in 2015 using the coupling method of Fenton oxidation and biodegradation. With that, I end my conclusion, and this are the references which I use to conduct my study for FYP. And with that, I thank you.